Hey guys, welcome back. We are almost done with Unit 1. You guys have a couple of lessons left, then we will review and of course take our assessment. So today we're going to take it kind of easy. This is actually, these last couple lessons, I would say they're one lesson that I've just cut into two parts, so hopefully it's a little bit easier for us to digest here. But today we're going to talk about forms of energy, and then tomorrow we're going to focus specifically on thermal energy. So it's kind of a two-parter. But today we're just going to go over the general definitions and talk about some of the types of energy, and then tomorrow we'll get into a little bit more with thermal energy to round out our very first unit. So let's go ahead and jump into today's lesson. So the first thing we have to do is define energy and talk about the difference between kinetic and potential energy. So energy is the ability to do work on objects, and there are two forms. Kinetic energy is the energy of a moving object, and it's because of motion. So anything in motion has kinetic energy. Potential energy is stored energy due to an object's position. So I know you guys can't see me because I'm on a YouTube video, but if I were to take a pencil, and I do have a pencil here with me at my desk, if I were to hold a pencil up stationary, meaning it's not moving, if I just hold it in my hands above my head, that pencil has potential energy. Okay, so I'm holding it, it has the ability to do work, I'm just holding it in position right now. If I release the pencil, as the pencil is moving through the air until it drops on the ground, that's going to have kinetic energy because it's in motion. Okay, so kinetic energy in motion. Remember, molecules have kinetic energy, and their kinetic energy increases based on the phases that they're in. So solids would have low kinetic energy, and then our gases would have high kinetic energy. So let's talk about some of the forms of energy. So energy can be transferred or converted from one form to another. And we're going to focus on thermal energy tomorrow, but all forms of energy we do need to touch on. So mechanical energy is energy associated with the motion of an object. So examples of this would be chewing, sound, and then here we have a Looney Tunes picture of a frog dancing. He is in motion. He has mechanical energy. Okay, when you're chewing up your food, your hot Cheetos, your Takis, whatever it is that you kiddos like to munch on, that is mechanical energy. Thermal energy, or heat, that's the total energy of the particles in a substance or material. Remember, yesterday we talked about how if you increase the thermal energy or increase the heat of matter, specifically we looked at water, it will go through those phase changes. So as you heat it up, its kinetic energy increases, and then we can go from a solid to a liquid to a gas. So all objects give off thermal energy. Ice cream melting gains thermal energy, right? So as this ice cream is gaining its thermal energy, it's going through that phase change. It's melting. It's going from a solid to a liquid. Chemical, also known as atomic energy, is the potential energy that's stored in chemical bonds. So remember, when we eat, we get our energy from our food, and that energy, the potential energy, is stored in the chemical bonds of that food. So examples of this would be food, firecrackers, your stomach acid, and then also a battery. So a battery would hold potential energy as well. Light or radiant energy, this is energy contained in beams of light. So this would come from the sun, light bulbs, or any source of radiant light. Now, you guys have been through both biology and earth science at this point. So you guys know that the sun is the source of energy for photosynthesis, which is how plants make its food. And then, of course, we eat the food for respiration so we can get our own energy. Electrical energy, that's moving electrical charges that produce electricity and energy. These are things like static shock. So if you've ever worn socks on a carpet and kind of shuffled across the carpet and then touched a metal doorknob, you get that static shock. Lightning would be electrical energy. Computers, TVs, radios, your phones that we all love so much, and then lights as well. Those have electrical circuits in them, and that is a form of energy. Sound energy is caused by an object's vibrations, and of course that's sound waves. So if you guys, we can use lightning and thunder here as an example. So lightning is both light energy and electrical energy, and light moves quicker than sound does. So light is a wave that hits our eyes, and that's how we see the world around us. But sound is also a wave as well, and sound waves move slower than light waves. That's why you always see lightning before you hear thunder. But those sound waves are picked up by the delicate bones and muscles that we have in our ears and then interpreted for us. And the last form of energy we're talking about today is nuclear power. And this is energy stored in the nucleus of an atom from either fission or fusion. And this comes from the sun, stars, and nuclear power plants. Now, really quick, let me give you a refresher from earth science, because I know this is what they teach you in earth science. Remember that the center of an atom, it can be split, right? That's through a process called fission. So fission just means to break apart. Fission is man-made. When we split an atom, the radiation can be used then to power a power plant. It heats the water, which creates steam, which turns a turbine, which gives us electricity. Okay, and that's electrical energy. Fusion is a natural process. So fusion is what happens in stars and our sun. It's when two lightweight elements come together to form a heavier element, and then the radiation that's kicked off comes to the earth, which then gives us our radiation for photosynthesis. Okay, so nuclear power just refers to the nucleus of an atom. That's why we call it nuclear power. But fission and fusion are two distinct things. So fission is breaking it apart. That's man-made. It powers our power plants. And then fusion is coming together. That happens naturally in our sun and our stars. Okay? So that's it. Today we're just exploring the different types of energy, understanding that there are different types of energy out there. And then tomorrow we're going to focus specifically on thermal energy for us in this class. Okay? So that's it for today. A pretty short one, but if you have questions or need anything, let me know. And as always, I'll catch you guys in tomorrow's lesson. Bye, guys.